Hey everyone, today we're going to continue simplifying, multiplying, and dividing rational expressions. We're going to try some harder examples. So if we look down here, this first one, I'm going to start just by factoring all of the expressions. This is going to be a sum of cubes. So I'll put sock. And remember, if we have a sum of cubes, we can factor it using this property. We have a plus b times a squared minus ab plus b squared. Remember, when you're factoring it, if there's a plus, then the first parenthesis should have a plus, and then the second parenthesis, you'll have the opposite sign. If I have a difference of cubes, this is the property. We would have a minus b, a squared plus ab plus b squared. And in that case, we see a similar pattern where if there's a minus, the first parenthesis has the minus, and then the second parenthesis there has the opposite sign with the plus. Okay, because this is a sum of cubes, we're going to be using this first property, and we have to figure out what x cubed and 8 are perfect cubes of. So what is the cube root of x cubed? Well, that's going to just be x, right? And what is 8 a perfect cube of? Or what is the cube root of 8? That would be 2, right? Because 2 times 2 times 2 is 8. Okay. So now I know what to replace. Everywhere I see an a, I'm going to be replacing it with x. And everywhere I see a b, I'm going to be replacing it with 2. So we'll have x plus 2, right? A plus b. We have a squared, so that's going to be x squared, minus ab. A is x and b is 2, plus b squared. And b squared, that's going to be 2 squared. All right, so that gives us our factorization for the first part. Okay, so we'll highlight that in purple. This first part right here, we just factored that. Okay, then we move on to the next part. I'll put times x minus 2. Can't really factor that using any property, so I'll just put the factor x minus 2. And in the denominator, we have x squared minus 2x plus 4. Can we factor that? X times x is x squared. Okay, what are some things that multiply to give us 4? 2 times 2 or 4 times 1. Here, my outers and inners, there's no way to get a negative 2x. And if I use the 4 and the 1, let's see, 4 and 1, my outers are 1x, or my outer is 1x and my inner is 4x. Again, there's no way to get the negative 2x. So this trinomial actually does not factor. Because it's not factorable, we'll just leave it like this. X squared minus 2x plus 4. Then we have divided by. Let's go ahead and factor the numerator now. X squared minus 4 would be x plus 2, x minus 2. And x minus 6 does not factor, so we'll leave that as x minus 6. Okay, so we did factor that numerator. I'll go ahead and just highlight it in pink so we know that we factored that. All right, so now we're just going to work our way from left to right, where I'm going to start with this multiplication. And remember, with multiplication, you're going to cancel one factor from the numerator with one common factor from the denominator, if it applies. And then we have a division symbol here, so don't forget that we're going to end up having to change that sign to multiplication and flip that second fraction. Okay, we want to get everything in multiplication before we start canceling things. You don't want to cancel when you see a division sign. Okay, you want to multiply by the reciprocal. So let's clean this up. The first part's going to look like x plus 2, x squared minus 2x plus 4 times. We have x minus 2 in the numerator, and this trinomial did not factor. Then I'm going to change the sign to multiplication and flip this fraction. All right, so now everything's in multiplication form. So now I can cancel one factor from the numerator with one factor from the denominator. See what we've got. Look at this. X squared minus 2x plus 4 would cancel with the x squared minus 2x plus 4 factor. We've got this x plus 2 will cancel with this x plus 2. And this x minus 2 will cancel with this x minus 2. And so all I'm going to have left in the numerator is x minus 6. Now, I'm not quite done yet. I don't want to circle it quite yet because I haven't done my domain. Let's go through everything in the denominator you have to consider. Remember, we don't want to divide by 0, so we're going to have to restrict anything that gives us 0 in the denominator. So what would make this denominator right here equal to 0? Well, let's see. That we already know is not factorable, so I'm going to go ahead and use quadratic formula. X equals negative b. Opposite of b would be a positive 2, plus or minus the square root of b squared. Well, b is negative 2, so if I square that, I get 4, minus 4ac. A was 1, c was 4, all over 2a. Okay, and look what's going to happen in that discriminant. 4 minus 16. Do you see how we're going to get a negative under that root? So I know that this would be imaginary. So I'm not going to worry about that factor. Now here, I know that x cannot be 6, because if x was 6, do you see how we'd get 6 minus 6, which is 0? Don't want to divide by 0, so we have to restrict 6. Okay, look at these denominators. Again, I know this is imaginary. Here, x can't equal negative 2, and here x can't equal positive 2, because then we would be dividing by 0. Okay, now in my answer, do I have any domain restrictions if this is over 1? No. So right now it's not equivalent. In order for an expression to be equivalent, they have to have the same domain. So I'm going to have to put a reminder in here that x can't equal 6. What else can't x equal? X can't equal negative 2, and x can't equal positive 2. Okay. And actually our answer might have looked better if we put the lowest domain restriction first. So we'll say x can't equal negative 2, positive 2, or 6. Those are the things that x can't equal. Okay, you're welcome to list them out this way as well. That works perfectly fine. All right, let's see about this next one. Instantly I'm seeing division and thinking, copy, change, flip, multiply by the reciprocal. We're going to start the same way, where we factor everything first, and then we'll flip that second fraction. We'll do our copy, change, flip. Okay, so this first guy here, let's go ahead and factor that. 2x times x is 2x squared. 1 and 5 would multiply to give you 5. So maybe do 1 and 5 like that. My outers are 10x, and my inners, we get 1x. So really, there's not going to be a way to get to 3x using that factorization. So let's flip it. Put the 5 here, the 1 there. Let's see if that works any better. Now I've got 2x as my outer, and 5 times x is 5x, and that's my inner. That I can get 3x from. This would have to be a plus 5 and a minus 1, right? Plus 5x and minus 2x would give me 3x in the middle. That looks great. Okay, so we've got our factorization. This is over 6x. Then if I factor this guy, we know that's a GCF, so I'll put divided by x times 2x plus 5, right? I divided out a GCF of x. All right, now let's do our multiply by the reciprocal. We'll get 2x plus 5 times x minus 1 over 6x. Right, we're changing the sign and flipping the second fraction. So really, if I think about flipping this, we're going to get 1 over x times 2x plus 5. Now that it's multiplication, we can cancel one common factor from the top with its common factor from the bottom. Okay, so the 2x plus 5s will cancel, and that's it. You cannot cancel these x's because they're both in the bottom. Okay, you need one from the top with one from the bottom. So I think that's really it. Now let's multiply straight across. If I go straight across the top, x minus 1 times 1 is just going to give us x minus 1. And if I multiply straight across on the bottom, 6x times x is going to give us 6x squared. And here we go. We just got to write the domain restrictions if there are any. Remember, we just need to look at what makes the denominator equal 0. We do not want to divide by 0. So here, x can't equal 0 because if it was, 6 times 0 is 0. I do not want to divide by 0. Here, there's just a 1 in the denominator, so I don't have to worry about that. Down here, again, x can't equal 0. Here, your domain's fine. Don't have to restrict anything. Here, x can't be 0. Here, x can't be 0. Also, what else can't x equal? X can't be negative 5 halves. I know that because if I set 2x plus 5 equal to 0 and solve it, we subtract 5 from both sides and then divide by 2, we end up solving to get negative 5 halves. Okay, so we cannot have negative 5 halves because it would make this denominator equal 0. Okay, so we've got to restrict that from the domain. So what do I see in my answer? In my answer, all I can see is that x can't be 0. So that's already a part of my answer's domain. Is there anything that I'm missing? Okay, got x equals 0. This -5/2 I have to write in as part of my answer because I cannot see that in my answer currently. Okay, there we go. Last but not least, we're doing the same thing down here. We got to factor everything first. Once it's factored, we're going to copy the first, change this to multiplication, and then flip the second fraction. You've got to get multiplication before you start canceling. And I use the word canceling, but really what we're doing is we're dividing common factors to give us 1. Okay? So let's go ahead and factor everything first. So set up our parentheses. This first guy right here, we have 2x times x is 2x squared. Last times last gives us -5. So let's see, maybe we do 5 and 1. My outers here are 10x. My inners, we get 1x. That does not work. We flip it. Try the 5 first. My outers, we get 2x. Inners, we get 5x. You can get 3x from that. This would have to be 2x plus 5 and x minus 1. Okay, my denominator is x minus 1. That doesn't factor any further. This guy over here, we've got 3x times x is 3x squared. What multiplies to give me 2? Maybe 2 and 1. Here my outers would be 6x and my inners 1x. That's not going to give me a 1x in the middle. Let's flip this, maybe try the 2 here and the 1 there. We would get 3x on the outside, 2x on the inside. Yep, that would work. It would have to be a positive 3x on the outside and a negative 2x on the inside. Okay, so that I think works. First times first is 3x squared. My outer is 3x, my inner is -2x. So that does sum to x. And then last times last is -2. That looks good. Okay, denominator, I factor this is a difference of squares. Remember, difference of squares, we use a plus b, a minus b. So this would end up being x plus 1, x minus 1. Right? X squared is a perfect square of x, and 1 is a perfect square of 1. Okay, now that's all factored. We can copy, change, flip, multiply by the reciprocal. Okay, I'm going to copy the first expression exactly how it is. I'm going to change the division to multiplication, and I'm going to flip the second fraction. X plus 1, x minus 1 over 3x minus 2, x plus 1. Okay, now that it's multiplication, I can start canceling 1 from the top with 1 from the bottom, right? We're dividing out common factors. That gives us 1. Okay, let's go ahead and cancel. Let's do these x minus 1s. What else? I've got these x plus 1s. And I think that's it. Okay, so now I multiply straight across the top. Top times top, we would get 2x plus 5 times x minus 1. Bottom times bottom, we'll end up just with that 3x minus 2 factor. Okay, we're almost done. We got to look at the domain, see if it's the same as the beginning. In the beginning, before we did the copy, change, flip, x cannot be 1, x cannot be -1, x cannot be 1. After the flip, x cannot be 1, x cannot be 2/3, and x cannot be -1. I know that this is 2/3 because, again, we're trying to figure out what makes the denominator equal 0. If I add 2 to both sides, we get 3x equals 2. And if we divide both sides by 3, we get 2/3. So you can see if I plugged in 2/3, I would end up getting a factor that's equal to 0. Right? We don't want the denominator to be 0 because then the expression is undefined. Okay, what do I see in my final answer? I see that x can't be 2/3. Let's put -2/3. X can't be +2/3. I see that in my answer already, so I don't need to write it in. What am I missing? I'm missing that x can't be 1, that x can't be -1, right? And I already said 1. And I already said -1. Okay, so I'm going to say that x can't be -1 and x can't be +1. We need to write that into our answer because I don't see that, and I don't see that domain restriction in my answer currently. All right, and that's it.